Welcome to the 37th lecture of digital electronics. In this lecture, we will be dealing with how to reduce Boolean expressions using K-map. So, before going into the lecture, let me take the example of two variable K-map. In the case of two variable K-map, what we have is if we are having the min-term type of representation, we are having A or B, if you are having match terms kind of representation, you are having A or B bar, A bar or B, A bar or B bar. Okay. And similarly, if you are having this min-term expressions, again, min-term expression, this will be A bar, B bar, A, B. If you are having min-term expressions, you are having what? A bar, B bar, A bar, B bar, then A bar, B, A bar B, then AB bar and AB. Okay, these are the corresponding min-term expressions. Okay, so if you are writing the terms, you can instead of this zero, you can write A or B. Instead of this zero, you can write what? A or B bar. Instead of this zero, you can write A bar or B. I think you have got the point, right? Okay. Now, in the case of three variable also you can do the same, as well as in the case of four variable also you can do the same. That means M0, that is, it can be written as A bar, B bar, C bar, D bar. M1 can be written as A bar, B bar, C bar, D. M3 can be written as A bar, B bar, C, D. Okay. That means each cell, instead of this ones and zeros, we can replace it by the corresponding min-term and match term. Okay. Now, if I am drawing a K-map, I am drawing a two variable K-map in min-term form. Then it is having four cells. Okay. So A, B, 0, 1, 0, 1. This is A bar, B, sorry, A bar A. This is A bar, this is A. This is B bar, this is B. This term is A bar, B bar, first term. That is M0. M1 will be what? M1 will be A bar, B. M2 will be A, B bar. M3 will be A, B. Okay. That is in min-term form. If you are writing the two variable K-map in match term form, can write like this, having four cells, A, B, 0, 0, 1, 1, this is 0, 1, 2 and 3. We are having A bar, B, B bar. This we can write it as A or B. This is A or B bar, A bar or B. The last one is A or B. Okay, that is a corresponding match term representation. Similarly, in the case of three variable K-map, we are going for three variable K-map. Okay. You can write like this. This is say A, B, C, 2, 3. So if I am going for min-term type expressions, then I can go with this is 0, 1. So 0, 0, 0, 1, 1, 1, 1, 0. This is A bar, A, B bar, C bar, B bar, C, B, C, BC bar. We are having 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So this is A, B bar, C bar. This is A, B bar, C. This is A bar, B, C. This one we can add as A bar, B, C bar. And M4 we can add as A, B bar, C bar. A bar. So this is A, B bar, C bar. Here what we have is A, B bar, C. This is A, B, C. This is A, B, C bar. Okay. If you are writing the match term form, of this three variable K map, this is min term form. If you are writing the match term form, you can write in this way. So let me draw the three variable K map. A, B, C, 0, 0, 0, 1, 1, 1 and 1, 0. This is 0, 1, A bar. This is B or C, B or C bar, B bar or C bar, B bar or C. So here what we are having is A or B or C. This is A or B or C bar, A or B bar or C bar, A or B bar or C. Here what we are having is A bar or B or C. This is A bar or B or Z bar, A bar or B bar or Z bar, A bar or B bar or C. Okay. So this is the corresponding match term type representation of three variable K map. So coming to the last type of K map which we need to study is four variable K map. Coming into four variable K map. Four variable K map. To have the min term representation. To have the min term representation. Having a four variable K map. 2, 3, yeah. So this is A, B, C, D, 1, 2 and 3. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So here what we are having, this is A bar, B bar, C bar, D bar. So here we are having A bar, B bar, A bar, B, A, B, A, B bar. And this is C bar, D bar, C bar, D, C, D, C, D bar. So here what we are having is A bar, B bar, C bar, D. This is A bar, B bar, C, D, A bar, B bar, C, D bar. Then this is A bar, B, C bar, D bar, A bar, B, C bar, D, A bar, B, C, D, A bar, B, C, D bar, A, B, C bar, D bar, A, B, C bar, D, A, B, C, D. This is A, B, C, D bar. So here what I am having is A, B bar, C bar, D bar, A, B bar, C bar, D, A, B bar, C, D, A, B bar, C, D, A, B bar, C, D bar. Okay. So these are the corresponding min terms. If you are going for the corresponding match term type expressions, so going for the corresponding match terms, one, 2, 3, 1, 2, 3. So I am having A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 0. This is A or B. A or B bar. A bar or B bar. A bar or B. This is C or D. C or D bar. C bar or D bar. C bar or D. So if you are looking to these terms, Here you will get A or B or C or D. So you will get A or B or C or D bar. This is A or B or C bar or D bar. This is A or B or C bar or D. A or B bar or C or D. A or B bar or C or D bar. This is A or B bar, A or B bar or C bar or D. Here what we get is A or B bar or C bar or D. C bar, this is C bar or D bar. Here what we get is A bar or B bar or C or D. A bar or B bar or C or D bar. A bar or B bar or C bar or D bar. A bar or B bar or C bar or D. Here what we have is A bar or B or C or D. A bar or B or C or D bar. A bar or B, A bar or B or C bar or D bar. A bar or B or A bar or B or C bar or D. Okay. So if you are having the corresponding min-term and match-term expressions, if you need to get A in match-term, you need to take the first two rows. That is all. If you need to get A or B, then first row can be taken. If you need to get C or D, the first column can be taken. Similarly, you can take in the case of min-term. If you need to get A, you can take the last two rows directly. If you need to get A bar, first two rows. If you need to get C bar, C bar means you need to take first column as well as second column. You will get C bar. If you need to get C bar, D bar, the first column only. Okay. So that is the way in which we are going to reduce the expressions. Okay. So here the major advantage is that you can simplify this in the form of pairs, quads, octets, and this one, and 16. Yeah, and 16. Okay. These are the four forms in which you can reduce an expression. Okay. So how to take pairs, how to take quad, how to take octet, and how to take it as a whole. That part we will deal while doing a problem. Okay. So I think it is sufficient to I think the explanation is sufficient how to reduce an expression. In the case of this 2 variable, 3 variable, as well as 4 variable k-map. Okay. So how to take pairs, how to take quads. Quads means combination of 4. How to take octets. These all things can be dealt with the help of a problem. Okay. So suppose if you are having an expression, so the question is reduce the expression f is equal to a bar b bar or a bar b or ab. So here you are going to use k-map for the reduction of the expression a bar b bar or a bar b or ab. So first of all, basically it is having only two variables, and this is in sum of product form. So we can draw a two variable k-map. Yeah. So this is A, B, 0, 1, 0, 1. Here you have A bar, A, B bar, B. Yeah. First one is A bar, B bar. A bar, B bar means the first term only. So you will get 1. This is SOP. A bar, B. A A bar B. That means the second term. Here you will get 1. Third term is AB. AB means A B. That is this term. Now how you can pair? Now see here there is one in the first row only. That means here we can pair these two. We can pair these two terms. If you are pairing these two terms, the corresponding expression is A bar. Again, these two you can pair. Okay, these two you can pair. That means here you will get B. Therefore, the corresponding reduced expression is F is equal to A bar or B. That is the corresponding reduced expression. So here I have given the example of taking pair. Pair means it can be taken using this adjacent cells. That is how we are taking a pair. So this is basically, if you are drawing a simplified gate, you will get A bar. So A B. So this is A bar. So here you get A bar or B. Okay, this is the most simplified version of this expression given in SOP. That means using KMUP you can get the most simplified expression directly. So coming into the second question, reduce the following expression. Reduce the following expression. F is equal to A or B and A bar or B and A bar or B bar. Okay. So this is basically in product of some form. So first I draw the KMUP directly. In product of some form. So here you are having A B. This is 0 1. So you have A bar 0 1 B bar. Okay. So first term is A or B. Yeah. How to take A or B? So if it is in product of some form, you should write 0. A or B means this. So this is 0. A bar or B. A bar or B. That comes this term. Then you will get A bar or B bar. A bar or B bar. You will get this term. Okay. Now you can take the pairs. These two can be paired, right? So what do you get? What do you get is B. These two can be paired. Okay. So here what do you get? You will get A bar. Okay. Now if you are simplifying the expression, what do you get? F is equal to if it is POS form, how we can reduce it? If it is POS form, we can reduce it as what? A bar. So you will get A bar or B. A bar or B. Okay. Now if you have a doubt in how you have reduced it to A bar or B, I will just show I will show the explanation just by expanding the term. So we have F is equal to A or B and A bar or B and A bar or B bar. Okay. So you just expand the first two terms. You will get A bar or A B or A bar B or BB or BB. Yeah. And A bar or B bar. A bar is 0. Okay. So here what we get is AB or A bar B or B and A bar or B bar. Okay. Again, if you are further simplifying it, see in these two terms, this is common, B is common. So you can write it as A and B and A1. It is B and A or 1 or A bar B and A bar or B bar. Yeah. So here what do we get? Here we get what? Yeah. B or A or 1. B or A or 1. Yeah. Okay. So A or 1 is A or 1 is 1 itself. So it is B or A bar B and A bar or B bar. Okay. So here what it is? Here what we are getting is B. This is B and A bar or 1 and A bar or B bar. Yeah. Now if you are further simplifying it, what we get is, simplifying this equation number 1, what we get is F is equal to A bar or 1 is 1 itself. So you get B and A bar or B bar. So what is the corresponding answer? The corresponding answer is what? F is equal to A bar B. Is equal to A bar B. Okay. Since I have expanded this, I am getting in SOP form. Okay. And if this is the corresponding what I am getting is POS form. Okay. This is A bar B. Yeah. Okay. That is A bar B means that is a corresponding SOP form, and this is the corresponding POS form. Or we can write it as, what is this? This is pi m A or B. A or B means this is 0. A bar or B. So we are having 2 and this one 3. Okay. Now here what? So what is the corresponding SOP form? That is sigma m of 1. What is 1? 1 is A bar B. Okay. So what you are getting in min term is same as what you are getting in match term form. Okay. That means you can reduce the two variable K, reduce a big expression using KMR into POS form as well as SOP form. In both cases the answer is correct. Now coming into the third question. Reduce reduce the expression. Reduce the following expression. Reduce the following expression. The question is given by F is equal to A or B and A bar or B bar, A or B bar and A bar or B bar. Okay. Now this is basically in two variable form, and that too again in product of sums form. So draw the K-map. So here what we are having is A, B, 0, 1, 0, 1. This is A bar, B, B bar. So A or B. A or B means what? This term. So here we get 0. Then since this is POS, we will get 0. A or B bar. A or B bar. That is this term. 0. Third term is A bar or B bar. A bar or B bar. That is this term. Okay. Now if you are writing the corresponding corresponding match terms, you will get it as what? This is 0, 1, 2 and 3. The corresponding match terms we can write it as F is equal to pi capital M 0, 1, 3. Okay. Now if you are simplifying the expression in POS form, these two forms a pair. So that gives A, because A is really common. Another thing is these two forms a pair. That forms B bar. Therefore, the simplified POS expression is F is equal to A or B bar. That is a simplified POS expression. Okay. Now, if you are going for this min term expression, f is equal to pi m 0, 1, 3. Therefore, the corresponding min term you can write as f is equal to 0, 1 and 3 is reserved there. So you can write as sigma m of 2. Okay. What is it? That is equal to small m2 only. What is small m2? You will get 1, 0. So what is it? That is equal to a b bar. It's equal to a b bar. That is the corresponding midterm expression. That means whatever numbers are there in match term, that will not appear in midterm. So we can write it m2. That means you will get a b bar. Therefore, the most simplified form is either we can do with a or b bar in BOS form, or we can write with a b bar in SOP form. Okay. In both ways it is correct. Okay. That means if you are getting min term or match term, actually what you are getting is the duals. Okay. Actually what you are getting is the duals. Okay. If you are getting the duals, both are correct. So min term I will realize the min term. So here you will get a b bar. So this is a b bar. That is min term realization. Using max term realization, you can draw like this, having a or b bar. So here we get this a or b bar. Okay. So hope you have understood how to take pairs. Okay. So this is the way in which you can take pairs. Whereas if you are getting the SOP form, one can be paired. In POS form, zeros can be paired. Okay. So I think you got the concept of how to reduce a expression using this K-map. Now coming into this 3-variable K-map. Okay. So coming into the example of this 3-variable K-map, how to reduce the expression using this 3-variable K-map. Okay. So we'll start with an example. So reduce the expression. Reduce the expression. Yeah. Reduce the expression. F is equal to a bar b bar c. F is equal to a bar b bar c, or a bar b c bar, or a b bar c, or a b c bar, or ABC. Okay. Since you are having these 3 variables, here you are having 3 variables, and again that is in sum of products form. So let me try to do it first. Draw the K-map. Just draw in the K-map. Okay. So here we are having A, B, C. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So here you are having A bar, A, B bar, C bar, B bar, C, B, C, B, C bar. Okay. So here if you are writing the corresponding decimal equivalence, 0, 1, 2, 3, 4, 5, 6, and 7. So now let me map term by term. First term is A, B bar, C bar. So to get A, B bar, C bar, that is this term. You will get 1. Second term is A bar, B, C bar. A bar, B, C bar, that is this term. Third term is A, B bar, C. A, B bar, C, that is this term. Fourth term is A, B, C bar. So you will get A, B, C bar, that is this term. Last term is ABC. So you get A, B, C. That is this term. Okay. And all other terms are 0. Now if you need to get a simplified expression, what you can take? If you need to get the simplified expression, what you can take is, you can simplify you can take this row because all are 1, right? So this is known as quad. You can take the quad expression. So if you are taking the quad, you will get A. And you have missed this one. So you can take these two as a pair. So if you are taking the pair, what do you get? BC bar. Therefore, the most simplified form of this expression is f is equal to A or BC bar. That is the most simplified form. And if you are representing in terms of min terms, if you are representing the expression in terms of min terms, what do you get? F is equal to sigma m 2, 4, 5, 6 and 7. Whereas if you are representing in terms of math terms, then it does f is equal to pi m pi capital 0, 1 and 3. Now if we need to get the match term representation of this one, I will write as, here you will get A, this is A bar, this is B or C, then this is B or C bar, this is what? This is B bar or C bar. Okay. Now if you need to get the minimized match term representation. Minimized match term representation. Here what we can do? You cannot club 3. So because here you are having 0, 0, 0, that means you cannot club 3. But what you can do? You can club 2. If you are clubbing these two, what do you get? A is common. Then which is common? B is common. So you can write f is equal to A or B, and this is the last term. Here what we get? A or these two you cannot club because it is not differing by 1 bit. But can you club these two? Can you club these two? Okay, you cannot club this one and this one. Okay, because it is different by 2 bits. Whatever is differing only by 1 bit, you can club it. So if you are clubbing these two, what is common? A is common, and these two, which is common? C bar is common. So you can write A or C bar. Okay. So this is the minimized match term type representation. Okay, that is given by pi m 0, 1 and 3. Hope you have understood. How to minimize the given expression into minimized min term as well as minimized match term. Okay. So coming into one more question in this lecture. So coming to the question, minimize min term form and match term form. Okay. So we need to go with minimized min term and minimized match term, as well as we can write the min term and match term. So the question is given by f is equal to A or B or C. F is equal to A or B or C, and A bar or B or C bar, and A bar or B bar or C bar, A bar or B bar or C bar, and what? A or B or A or B bar or C bar. Okay. So the given expression is in which form? The given expression is in product of sums form. So first you draw the K-map. I'm drawing the K-map directly. Okay. K-map. So here what we have is A, B, C. 0, 0, 0, 1, 1, 1 and 1, 0. 0, 1. Since this is POS form, this is A bar. This is B or C. B or C bar. B bar or C bar. B bar or C. Okay. So if you are writing the corresponding decimal equivalents, you will get it as 0, 1, 2, 3, 4, 5, 6 and 7. Now write the first term. What is the first term? So the first term is A or B or C. So A or B or C means system. You will get 0. Second term is A bar or B or C bar. So this term is there. Third term is A bar or B bar or C bar. A bar or B bar or C bar. That is system. Last term is A or B bar or C bar. A or B bar or C bar. That is this term. Okay. Now here we can take pairs, right? So here if you are going for this pairs, you can pair these two. If you are pairing these two, what do you get? Here what you get is B bar or C bar. Again, you can pair these two. If you are pairing these two, because that is only variable by that is only varies by 1 bit. So here, if you are pairing it, what do you get? A bar is common, then it is common. C bar is common. So it is A bar or C bar. So here what happens is that this term is standing out. Here this you cannot simplify. So this term we can write it as A or B or C. Okay. Therefore the most simplified form using POS form is F is equal to A or B or C, A or B or C, and A bar or C bar, and B bar or C bar. Okay. So that is the most simplified form using this min-term expression. And if you are, and the corresponding the min-terms, the corresponding match terms. This is the minimized match term. So if you are writing the corresponding match terms, you can write it as pi capital M 0 3 0 3 5 and 7. Yeah, and that means we can write the min term as F is equal to sigma M 1 2 4 and 6. 1 to 4 and 6. That means here we can take ones. Ones in the case of this min terms. So you will get 1 1 1 1. So if you are going to simplify this min terms, here what we get? This is A bar A. Here what we get? This is B bar C bar, B bar C, B C, B C bar. So here we can take a pair. So here what we get? What we get is BC. Yeah. These two you cannot take pairs because it differs by 2 bit. But here what you can take it? Can you take these two as pairs? The first element and last element. See, this is 0 0 and this is 1 0. And so that means it differs only by 1 bit. So you can take like this one and this one. So here what is common? A is common and C bar is common. So this is A C bar. Therefore the minimized match term or minimized SOP form, you can write as F is equal to what is the first term? This one. Yeah, that means A C bar or BC. That is the minimized SOP form, and the corresponding SOP and this one standard SOP form. The standard SOP form, you can write it as F is equal to sigma. That is the sigma M 1 to 4 and 6. So using the same K-map itself, I have reduced the given expression into POS form as well as SOP form. Yeah. So this is the reduced POS form. That means if you are writing the reduced POS form, this one. Yeah. This is the reduced POS form, and this is the reduced SOP form. That means using K-map you can reduce the given expression into minimum number of variables, or you can reduce the number of terms. You can reduce the number of terms using K-map. Okay. So here in this lecture, what we have dealt is we have started with K-map, how to represent the K-map in min terms and match terms forms. That we have started with. We have started with 2 variable K-map, 3 variable K-map, as well as I have given the example of this 4 variable K-map. And I have started with an example because doing with an example is comparatively easy. So here what I have done is we have done with pairs, quads, octets, and if it is for variable kebab, we can map the entire system. Okay. Now, first you have started with the pairs. Okay. So pairs for this SOP expression. That is the first question. So this is a pair for POS expression. This is a pair for again POS expression. So three variable we have done with pair as well as quad, because quad means this one. If four cells can be mapped into a single thing, then that is known as quad. Okay, so we have done with quad. Here we have done with pairs only. Okay, so I think you have got the concept of how to deal with, how to reduce the expression using K-map. Okay, so here we are done with two variables as well as three variables. In the next lectures, we will be dealing with four variable K-map and how to reduce the expression using four variable K-map. Okay, thank you.